Hey again, everyone, it's Miss Famer. Now we are on to Unit 3, which is on factors. So first thing we talked about when we did the factoring unit was a prime number versus a composite number. A prime number, as you can see, is a natural number that only has two factors, which are 1 in itself. An example is 31. You cannot think of any other numbers, or there are not any other numbers, besides 1 times 31 that give you 31. Another example would be, I don't know, 5. So 1 times 5 are the only factors that multiply to give you 5. A composite number is just the opposite. It's any number that has more than two factors. So that's a lot of the numbers we think of. 24, because 24 has factors which are, of course, 1 in itself, but it also has 2 and 12, and 4 and 6. Oops, and I missed 3 and 8. So there's many factors here. So a number like 24 is what we call composite. 1 is sort of interesting, and a lot of times people don't know what 1 is because we say it's neither prime nor composite. Because think about it, 1, its only factors are 1 in itself, right? But does it really have a choice besides to have factors besides 1 in itself? Of course not. So those are the only factors which make it prime, but it's also kind of composite because there's no other factors that you could possibly have. So we say it's neither. So what are factors, as I'm talking about factors? 3 and 6, for example, are factors of 18. The way I think about factors is any numbers that multiply to a product. So in this example, they say that 3 and 6 are factors because they multiply to a product of 18. On the last slide, we talked about all these other factors. So we then went into talking about what we think a greatest common factor might be. And it's exactly what it sounds like. It's the biggest factor that two numbers have in common. So the greatest common factor is the biggest number that two factors have in common. So let's take a look at some examples. It says, consider the numbers 18 and 24. What is the GCF? In other words, what is the greatest common factor? So this gives you some reminders here about what you might want to do. Sometimes you might come up with factor trees if you don't know the factors of a number. And then we're looking for the largest number they have in common. So let's come up with the factors of 18. Factors of 18. Some people like to do factor trees. Some people like to just list them. I'm a list kind of person, so I like to do 1 times 18. I know it's 2 times 9, 3 times 6, and those are my factors of 18. Factors of 24. We just listed them before. They're 1 and 24, 2 and 12, 3 and 8, 4 and 6. So if I'm looking for the greatest common factor, I'm looking for the biggest number that they have in common. So let's see, the biggest number they have in common might be 6. Looks like 6 to me. That's the largest number that they have in common. So the GCF for 18 and 24 is 6. All right, I don't think we need to do more practice on that. So let's go ahead and look at greatest common factor with variables. So we have here 12x squared and 32x squared. So if I'm looking at 12x squared, I know the factors of 12 and 32 are what I'm concerned with first. So the factors of 12, I know are 1 and 12, 2 and 6, 3 and 4. Okay, and I know just by looking at it, I'm looking, okay, which one of these numbers also goes into 32? Well, I know, let's see, 8 times 4 is 32. So it's looking to me like the GCF here for the number part only is 4. In terms of the exponent, there's two ways you can think about this. You can see which one has the smallest exponent because then that's what they have in common. Or x squared we know is x times x. X cubed we know is x times x times x. So what do they share? They share 2 x's, so that is x squared. So the GCF, either way, is x squared, or 4x squared, excuse me. All right, let's do another one. Find the GCF of 10x squared y to the cubed and 15xy squared. So 10 and 15, I'm looking, I know their GCF is 5. So I'm looking at x squared and x. I see they share 1x. I'm looking at y to the third and y squared. They would share 2y, so that's 5xy squared for my GCF. All right, so once we got done talking about factors, what factors are, we actually did some factoring with expressions, not just whole numbers. So the first one we did was the difference of two perfect squares. That is, in other words, what we call sometimes dots. The difference of two perfect squares has to be a perfect square minus, that's a big one, difference. So perfect square minus another perfect square. The way that we factor this is we say, okay, what times itself gives us x squared? Well, I know that is x times x, and that goes in the front of our parentheses. What times itself gives us 9? Well, I know 3 times 3 gives us 9. And with the difference of two perfect squares, one is always a plus, and one is always a minus. We did also do a quick review on all these factoring methods, so you have that to reference if this is a little too fast for you. Also, you can always pause. All right, so let's do another one. This is one that commonly tricks people. If the whole number is in the front, when you do your factoring, you also have to put the whole number in the front of the parentheses. So what times itself gives you 4, 2, and 2. Now here, I know it's going to be a plus and a minus. 81, I know that is 9 and 9, but don't forget about the x to the 8th. So what's half of 8? That would be 4. So I'm going to have 9x to the 4th and 9x to the 4th. So I have 2 plus 9x to the 4th times 2 minus 9x to the 4th. Those are the factors of 4 minus 81x to the 8th. All right, another method we did was the sum and product method. This works for trinomials where the leading term is that invisible 1. So we always want to find two numbers that multiply to give us the last term. So multiply to negative 18 and then add to the middle term. So we want to find these two numbers. So what would we have here? Looking, I know 6 and 3. Maybe let's do a positive 6 and a negative 3. Let's check. Isn't 6 times negative 3 negative 18? Yes. 6 plus negative 3, 3? Yes. So then we take those numbers and we put them in our parentheses. So it'll be x plus 6, x minus 3. We also did factoring polynomials using the greatest common factor. So we were just finding the GCF before, and that's what you do to start. So what's the GCF between 4 and 8? Well, that's 4. And then what we do, I'm just going to slide that down a little actually. And then what we do is we look at the variables. So let's see, they don't have any x's in common, but they have a y in common. So the GCF is y. What you have to do with the GCF then is divide it by both of your terms, or however many terms you have. So the GCF comes on the outside of a set of parentheses, and on the inside is the answers when you divide. So 4 divided by 4, that goes to 1. We're left with an x squared, y over y, that goes to 1, so we're left over with an x squared, so that goes here. 8 divided by 4 is a positive 2. The y's go to 1, so this is my final answer. GCF always goes on the outside of the parentheses. What you get when you divide goes on the inside of the parentheses. Another couple methods we did were factoring by grouping and the AC method. So we did do quite a lot of review on this during the in-class review, but it doesn't hurt just to kind of go through one quickly. Steps are right here. They're also in your quick reviews. You always group the first two terms and the last two terms. So I'm going to group these two, group these two. It says take out a GCF from each set. They don't have to be the same. So what's the GCF in the first set of parentheses? It looks like it would be a squared. The GCF in the second set of parentheses may be a negative 1. Then what we do is we divide by the GCF. So I'm going to divide by a squared, divide by a squared, and over here I'll divide by negative 1, divide by negative 1. So let's check it out. So I have an a squared on the outside, and then when I divide, I end up with a squareds go to 1 plus 3. Over here, I have a negative 1 on the outside. When I divide by negative 1, I get a plus 3. Remember, this is the point in the problem where you want to check to make sure your parentheses are the same. If they're not, you've done something wrong, or maybe you need to factor a little differently. If they are the same, you can continue on. The numbers on the outside go in their own set of parentheses. The numbers that are the same on the inside, one set of them just comes down. This could be your final answer, but if you can factor further, you should. And I'm seeing in my first set, a squared minus 1 is the difference of two perfect squares. So I'm going to take that one step further and do a plus 1, a minus 1, and then continue to bring down the a plus 3. AC method has grouping right in it, except there's a few different first steps. So in the AC method, you always have to first multiply a times c. The a is your coefficient of your squared term. The c is your constant. So a times c in this case would be 5 times negative 6 which gives me negative 30. So my AC is 30. The reason I do that is because I now want to find, kind of like the sum and product method, two numbers that multiply to negative 30, but then I want to find two numbers that add to the middle term. So I'm looking for two numbers that multiply to what I got when I did AC, but add to the middle term of the trinomial. So let's think. Let's see, I'm immediately thinking 10 and 3, but it has to be negative. Could be 15 and 2 also. So what if we tried that? What if we did a 15 and a negative 2? Because 15 times negative 2 is negative 30. 15 plus negative 2 is 13. Now, we use this a little differently than we do in sum and product methods, so don't make the mistake and just turn this into a sum and product problem. What we do now is we take the first term and we rewrite it. What we're going to do with the 15 and the negative 2 is replace the middle term. So instead of writing plus 13m, I'm going to do plus 15m minus 2m, and bring down the last term, which was minus 6. So what I've really done is taken something that was 3 terms and turned it into something that was 4 terms. The reason is because when I have something that's 4 terms, I can then use grouping. So same thing as before. Ooh, I don't want that to happen. Group the, let me click back. Group the first 2 terms. Group the last 2 terms. Take the GCF out of each. So the GCF in this one looks like it'll be, what, 5m? GCF in this one seems to be possibly, let's see, negative 2. So we'll divide by the GCF. So here we end up with m plus 3. Over here, when we divide by negative 2, we end up with, again, m plus 3. We check our parentheses. They are the same. They're both m plus 3s, so we can move forward. So we take what's on the outside, we put them in their own set of parentheses, so I'll have 5m minus 2 times m plus 3. I cannot factor either of those any further, so I'm all set. Last thing we need to talk about is the quadratic equation. Then I think we're pretty much done. So quadratic equation is an equation we use when something just cannot be factored using one of our methods. We have 5 methods of factoring, but sometimes they won't work. And our last resort is always our quadratic equation, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, you used to have like little songs to remember it or whatever it might be. So do your best to try to know that quadratic equation. So let's try one using the quadratic equation. So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Now we need the a, b's, and c's. Remember, they come from our equation. The coefficient of your x squared term is your a. The coefficient of your middle term is your b, which in this case is a negative 1. Here is a positive 1. And our c will be negative 6. So let's substitute in. X equals negative b. So that will be the opposite of b. So instead of negative 1, we'll do 1 plus or minus the square root of b squared, so negative 1 squared, minus 4 times a, which is 1, times c, which is negative 6, over 2 times a, which we said is 1. So now you simplify. So I have 1 plus or minus the square root. Let's simplify in these parentheses here. So this would negative 1 squared is a positive 1, minus 4 times negative 6, all over 2. So sometimes it takes a few steps to simplify. All right, so then I have, let's keep going, x equals 1 plus or minus. Under the parentheses, I have 1 plus 24 over 2. Then I have x equals 1 plus or minus the square root of 25 over 2. All right, keep going. I know I can take the square root of 25. So let's keep it moving. So I have x equals 1 plus or minus 5. The square root of 25 is 5 over 2. So let's break this up. So now I have x equals 1 plus 5 over 2, or x equals 1 minus 5 over 2. So let's simplify those both separately. So in the first one, I have x equals 6 over 2, which I know is 3. And over here, I have x equals negative 4 over 2, which is negative 2. Now, if you get an answer that comes out nice like this, it probably means you could have factored that first expression differently if you had so chosen to, but quadratic formula always will work. Now, so one other thing I wanted to mention back when we're solving with quadratic formula is that it goes beyond factoring. It is actually now solving. If they ask you to just factor, you're just writing the two factors, not getting final answers for x. But if you notice in the last question and this question, they don't say factor, they say solve. Another sign is that it's equal to 0. So you want to make sure that you're actually solving. So let's start by factoring. To factor this, it looks like it'll be GCF method. The GCF appears to be x. So I'm going to divide both terms by x. So I'm left with x on the outside, and then x squared divided by x is just x. Those go to 1, so I'm left with plus 3. And then look, it says equals 0. So if I were just factoring, well, I wouldn't have this part. I would just have these, and I'd say, okay, I'm done, I factored. But when they ask you to solve, you're actually doing what I just did before. Let me find the page we were at here. And you're solving. And in this case, you don't always have to use the quadratic formula. Sometimes, remember, we just take both of our factors and set them equal to 0. So x equals 0 and x plus 3 equals 0. Here I have to do a little bit of solving to get x by itself. Subtract 3 from both sides. So my answers to this one are x equals -3 and x equals 0. So the difference between factoring and solving. Factoring means you just write the factors. You only do the factoring method, nothing else. Factoring and solving, that's when you first factor, but then take each factor, set it equal to 0, and solve. The quadratic formula also solves for you, which we already did here. I think I did that in the wrong spot before, but here's another one. You could, if you have time, try the quadratic formula for this one here, for x squared plus 4x plus 5. I think that is it for today. So hopefully you are refreshed your memories on factors, you know what factors are, you know all the different factoring methods, and you should also understand and be able to know the difference between factoring and solving. Factoring is just getting the factors. Solving is when we factor and then get those actual values for x. Hopefully you found this helpful. Thanks for watching the video, and hopefully this will help you in class tomorrow. Talk to you guys later.